So what we're going to look at right now, and what we look at a lot in this unit, is something called the unit circle. The unit circle is just a circle where the radius is 1 unit. And that's why it's called a unit circle. Now, any point that's on the unit circle can be labeled with an x-coordinate and a y-coordinate. Does that make sense? And anytime you do that, and you label an x-coordinate and a y-coordinate, you make a right-angled triangle. And for all of those right-angled triangles, you can use a squared plus b squared equals c squared. And if I would do a squared plus b squared equals c squared, 1 squared, what I get is the actual equation of a circle. So you've learned that lines are y equals mx plus b, parabolas are y equals x squared, and different things like that. The equation of a circle is x squared plus y squared equals 1. And then you could do transformations with it so that you could move it up and left and different things like that and get new circles with new centers. And if you changed the radius to 5, then it would be x squared plus y squared equals 5 squared, and that would be the equation of a bigger circle. And so there's different circles with different sizes, but the unit circle, when it has a radius of 1, that's the equation of a circle. Now, what we have that's interesting on the unit circle is if we draw a right-angled triangle again on our unit circle here, then any point is x comma y. And so that means this height would be whatever the y-coordinate is, and this length would be whatever the x-coordinate is. If you think about that, though, since it's a right-angled triangle, you can use SOHCAHTOA, sine, cos, and tan. And based on the angle, and here the angle is labeled at theta, if we did sine of theta, that would be the opposite over hypotenuse. And the opposite is y, and the hypotenuse is 1. So sine of theta is the same as the y-coordinate in the unit circle. And cos of theta is the same as adjacent over hypotenuse, which is just the same as the x-coordinate. So instead of labeling points on the unit circle with x comma y, we can instead label them with cos theta comma sine theta. The other thing is if you look at tan being the opposite over the adjacent, y over x, we also get that tan of theta is equal to sine of theta divided by cos of theta. Which is pretty cool, because if you take any angle that you would like, 22 degrees, you type into your calculator sine of 22 degrees divided by cos of 22 degrees and push enter. Then you go to your calculator and type tan of 22 degrees, you'll get the same number every single time. Because tan of any angle is always equal to sine divided by cos of that same angle. We also learned some new definitions. You learned sine, cosine, and tangent. We now learn the reciprocals of each of them. The reciprocal of cos is the secant ratio. So that means that secant of theta is the same as 1 over cos of theta. The reciprocal of sine is cosecant. So cosecant of theta is 1 over sine theta, and the reciprocal of tangent is cotangent. So cotangent theta is 1 over tangent theta. And since tangent theta was sine theta over cos theta, we'll also know that cotangent theta is going to be cos theta over sine theta, just the reciprocal of tan. So you see how tan is sine over cos. If you do the reciprocal of that, you would get cos over sine. So these are some new trig functions that you haven't done before. They're called the reciprocal trig functions. Okay. Now at the bottom of your page, you've got some space there. And what we're going to do right now is summarize three big ideas that we're going to use throughout this unit. In fact, we're going to use them throughout this unit and the next unit as well. The first big idea that we saw today was that points on the unit circle have the coordinates cos theta comma sine theta. So we're going to remember that our x coordinate on our unit circle is cos theta and our y coordinate on our unit circle is sine theta. The equation of our circle, big idea number 2, is that x squared plus y squared is equal to 1. What did the x coordinate stand for? Sine or cos? Cos. So we can rewrite this. Instead of writing x squared plus y squared equals 1, we can rewrite this because x is cos. Cos squared theta. That cos squared theta plus sine squared theta equals 1. Have you ever written sine squared or cos squared before? Did you ever have to do that in grade 11? Maybe not. So one of the things, the way that we write it, instead of writing it like this, because it could be a little confusing, does that mean the theta is squared or does that mean the whole thing is squared? Right? And so it's a little bit, you might not know. So mathematicians decided if you write it this way, it means just the theta is squared. So they said, well, how could we show that the whole thing is squared? Well, we could add brackets, but mathematicians got lazy writing so many brackets, so they decided, well, why don't we just write the squared in between the cos and the theta? Save us brackets, and then we can make sure that we can tell the difference between a cos squared or when just the angle itself is squared. So whenever we write sine, cos, or tan, or any trig function squared, we write it right after the cos, in between that and the angle. Yes? So that is big idea number 2. And big idea number 3 is that tan theta is always equal to sine of theta divided by cos of theta. So all of these relationships come by looking at the unit circle and just doing basic trigonometry, a squared plus b squared equals c squared, and SOHCAHTOA, sine, cos, and tan, and we get these relationships. What we can do with these relationships is going to be huge. We're going to do a lot of math with this as a result.